Hi guys, today we're going to talk about our first lesson, which is over the Pythagorean theorem. So before we begin, please go ahead and get a piece of paper and take down some examples and put this into your geometry binder or folder. So the Pythagorean theorem, why do we have this? We have this because sometimes when we have a right triangle, we want to know a length of a missing side. So the Pythagorean theorem is for finding the measure of a missing side of a right triangle. So when you look at a right triangle, first of all, we have to know that it's 90 degrees. So the box here indicates that it's 90. The two side lengths that come together to form that 90 degrees is called, will be called the leg. Now, directly across, this is your hypotenuse. Your hypotenuse is always directly across from the 90, and it's always the longest length. And again, this is only for right triangles. Now, it's called the Pythagorean theorem because the person who was credited for creating this theorem, his name was Pythagoras, and he was a Greek philosopher, and he was a mathematician. So, what does the Pythagorean theorem say? The theorem says a squared plus b squared equals c squared. So what does that really mean? The a and the b represent the length of the legs. So what we're going to do is we're going to take a length of one of the legs and square it, and add the length of the second leg and square it, and it's going to equal the length of the hypotenuse squared. So there's this nice visual here that shows how this works. Now this is a right triangle, and we know the sides 3, 4, and 5 also make a right triangle. So this just is a representation of how the theorem works. If you take 3, which is a leg, and you square it, you get 9. And notice 3 times 3 is 9, and there are 9 boxes. We take the length of the second leg, which is 4, and we square it. 4 times 4 is 16. And that should be equal to the length of the hypotenuse squared, which is 5. 5 times 5 is 25. Now, here's the cool thing. When you add these two, 9 and 16 together, you get 25. So we can see if you add up the boxes here with the 9 and the 16, you get the 25. So let's apply all of this and do our first real example. So we have an isosceles right triangle. Now, isosceles means two sides are the same measure. So let's draw this out. Two sides are the same, and usually we put this little hash mark on it, which indicates that they're the same measure. And we know it's a right angle triangle. So the two legs are 6 meters each. And we're trying to find the length of the hypotenuse to the nearest tenth. So let's go ahead and start by writing out our theorem. A squared plus b squared equals c squared. The two legs are both 6. So let's solve for c. 36 plus 36 equals c squared. We're going to solve for c by adding together the 36's to get 72. Now, our answer is not 72. The issue is the square. We want c, not c squared. So let's talk about something you already know, the square root of 25. Most of you would automatically just know that answer is 5. Or if I said, what's the square root of 64? Then you would instantly say 8. But why? So 5 squared is 25. Now, if I square root that, the square root and the square count as opposites and they cancel out. So that's why the answer is 5. The same thing with 8. If I square it and then square root it, the square root and the square cancels, and I get the answer of 8. Now, what happens when you have variables? If I have c squared and I square root it, the square root and the square cancels, and you're left with just the variable c. So let's come back to this example over here. If I want c, not c squared, let's just square root and have the square root and square cancel. Now with algebra, if you do it to one side, you must do it to the other. So we have c equals the square root of 72. Now this is an answer in radical form. That means square root form. Now we read here in the directions, it says to the nearest tenth. Now, depending on what calculator you use, it will either reduce the square root and put it in simplified radical form, or it'll put it in decimal form. And right now, the directions say decimal form. So let's grab a calculator and see what your calculator says. And let's see if we all can get the same answer. So when I type it in my calculator, I get 8.4852 on and on. Now to the tenths, that means one decimal place. And you have to look at the number next to it to decide if you're rounding up or down. And since it's above 5, the 8 is above 5, that means I need to round up. So my answer is 8.5 meters. Don't forget the unit. So let's put it down here. That's my answer, which that answer makes sense because across from the 90 has to be larger than the 6, and that would work. Now we have a second example here where now instead of finding the hypotenuse, we're going to find the length of a leg. Let's start with the same theorem, a squared plus b squared equals c squared. The two legs are now x and 8. And it doesn't matter what order you put these in. It could be 8 squared, then x squared. But the 13 is the hypotenuse, and it always stands alone. It always is by itself. So let's go ahead and work this out. 8 squared is 64. 13 squared is 169. On the previous problem, we were able to add these two together because, let's go back and look. Because c, the variable, was by itself, and we had to combine the 36's. On this problem down here, this is different. We're going to have to solve for the 64 by subtracting the 64 to the other side. So x squared equals 105. Now, just like before, I don't want x squared, I want x. So I'm going to square root that, square root the left side, square root the right side. So x is the square root of 105, but I want decimal form. So practice typing this into your calculator and rounding it off. When I type this in, I get 10.2469. So look at the 2 and say the number next to it, do you round up or down? And since it's less than 5, you're going to round down. So my answer is 10.2 feet. All right, let's go ahead to the second page. Now we're going to find the length of the diagonal. So really, this is a rectangle, and opposite sides are equal. So this is 11 inches, and this is 4 inches. So let's just kind of focus in on this triangle here. And the diagonal would be your hypotenuse. So a squared plus b squared equals c squared. The legs are 11 and 4. And again, it doesn't matter which order you put these in for a and b. So 121 plus 16 equals x squared. Let's grab a calculator. Ignore that bell. So let's square root each side. And x equals the square root of 137. So again, let's practice rounding this off. When I type this in, I get 11.70. So when I round it, of course, I'm going to round down. So my answer is 11.7. Now, here's something kind of new that we need to talk about. Sometimes they're going to just give you 3 side lengths, and they're going to say, hey, does this form a right triangle? And, we use the same theorem, and we're just going to prove that the left side equals the right side once you plug in the legs and the hypotenuse. So how do you know which length is the hypotenuse? Well, that's easy. You just find the biggest number. So since 16 is the largest number, we know that that has to be the hypotenuse. The 2 legs, again, we can just plug in for a and b. So this is like a big question. Are these 2 sides, the left side and the right side, equal to each other? And if they are, it's a right triangle. And if they're not, it's not a right triangle. So 64 plus 100. And then let's go ahead and square the 16, which is 256. Are these two sides equal? And again, if they are equal, it's a right triangle. And if they're not equal, it's not a right triangle. So that's 164, 256. Are they equal? Of course not. So is this a right triangle? No, because the left side does not equal the right side. Now, I already filled it in over here, but it says this theorem works kind of two ways. If it's a right triangle, then you can find a missing side using the equation. But just like we practiced, if you have the equation, you plug in the numbers, then you can decide if it's a right triangle. So we have one more example. And what we're going to do is we're actually going to find the distance between 2 points. And we can do that with Pythagorean. We don't really need the distance formula for that. So I'm going to plot these two. So go ahead and draw a graph on your paper and try this with me. This will be on your assignment in your quiz later. 1, 2, 3, 4. 1, 2, 3. So this first point, just to make it easier, let's call it A. And the second, let's call it B. So let's go back 2 and up 1. Now what we need to do is find the distance between these. So let's draw a line. And so I'm actually going to turn this into a right triangle. So you could either go up and over or over and up. So I'm saying you can either make it like this and make a right triangle, or you can make it like this and make a right triangle. I wouldn't draw it both ways. You choose. So I'm going to erase that one. So as you can see, we have a right triangle. Let's count the units of the sides. Here's 1, 2, 3, 4. That side is 4 units long. 1, 2, 3, 4, 5, 6. Now, as you can see, the hypotenuse, you can't really count it that way. So that's where we do the Pythagorean. A squared plus b squared equals c squared. So let's plug in the lengths of the two sides. 6 and 4. So 36 plus 16 equals c squared. Let's add these on your calculator. I get 52. And we're going to square root each side, so the square cancels. So c equals the square root of 52. All right, let's type this in. So I get the answer of 7.211. And so I'm going to round this down and say 7.2 is the length or the distance between the 2 points. Okay, so we're finished. Go ahead and go back to Canvas, and you're going to do a Now You Try and an assignment. And if you have any questions, please reach out and we're happy to help you. Thank you and good luck.